Welcome back to the GCSE Maths Pro YouTube channel. Today's video is a compilation of the whole topic of factorising, but specifically for foundation tier students only. So what we'll be looking at is, first of all, factorising into single brackets, where you find a common factor and pull it out and put everything else into a single set of brackets. Then we'll be looking at the start of factorising quadratics, where we have the x squared, and we need to factorise it into two sets of brackets, so into double brackets. We've got the trial and error method that we'll be looking at, and then we'll look at a little bit into factorising what we call the difference of two squares as well. If you'd like to look at the original videos, which are obviously in more depth and have more questions on each part of the topic, I will link them down below in the description. If you are a higher tier student, obviously all of this does apply to you. However, there is another separate video on everything for factorising for higher tiers. So it obviously includes a little bit more at the end as well that relates only to higher tiers. So it'd be better if you check out that video, which I will link now and also in the description. So let's start with this first question. Factorise 2x plus 4. So first of all, what do we mean by factorising? Well, effectively, a word that we're looking at is factor. A factor is something that will divide into another number or another term, okay? So we're going to be using the concept of the highest common factor for factorising. When we're factorising into single brackets, what we want to do is look at both terms here and see what is the highest common factor between them. So what is the highest common factor between 2x and 4? Now, this could be a number, it could be a letter, or it could be a combination of both. In this case, you can see that we don't have any letters in common. Only one of them has x. So we can't use a letter as a common factor, but 2 and 4, the highest common factor would be 2, as in we can divide 2 into 2, and we can divide 2 into 4, and that's the biggest number. So our highest common factor is what we're going to effectively pull out and put on the outside. So in this case, we've got 2 on the outside, then just put some brackets. The brackets effectively mean multiply. And then on the inside of the brackets, we're going to say, right, okay, well, we've pulled out 2. If I'm starting at 2 and I have to multiply it by something, how do I get back to 2x? Well, this one's pretty straightforward because 2x is just 2 multiplied by x, isn't it? So if I've already got the 2, the only thing that's missing is the x. So I'm going to put the x here, and then this 4 is a separate term. So the 2 on the outside you can see is positive, the 4 is positive. So we're going to put a plus because multiplying a positive by a positive will give us a positive. And then I go, right, I've got 2. How do I multiply that to get to 4? Well, I just need to times it by another 2, don't I? So I need to put 2 there. This is your answer. Now, factorising is the opposite process of expanding brackets. So you can always go and double check, okay, is my answer correct? What I'll do there is just re-expand the brackets. What I mean by that is just multiply it out again. So let's say 2 times x is 2x. Okay, yeah, that's what we had here. And then 2 times 2 is plus 4. Yep, that's what we had there. So I can double check that I factorised it correctly. In this case, I have. So your answer is 2, and then in brackets, x plus 2. So factorising is literally just looking at the terms you have, finding the highest common factor between all of them, and pulling that out on the outside. Then just figuring out, okay, what do I then need to multiply that by to get back to my original in the question? So let's try a few more. Factorise 120 minus 8y. Okay, well, it's going to be single brackets. I'll put those there to start with. What is my highest common factor between 120 and 8y? Okay, so you can see there's only a y in one of them. We don't have a letter in both, so we can't use a letter as a common factor in this case. Then we're going to look at a number. What is the highest common factor between 8 and 120? Well, it is actually, in fact, 8, because obviously 8 goes into itself once, and 8 goes into 120 15 times. So the highest common factor is 8. That's what I put on the outside of the brackets. Then I go, okay, well, I'm already at 8. What do I multiply by to get back to 120? Well, as we've just said, we have to times that by 15. So I'm going to put 15 here. Then I say, okay, I'm at 8. What do I need to multiply by to get back to not just 8y, but that's minus 8y, isn't it? We always have to take the symbol that's in front of the term as part of that term. So this is not just 8y, it's minus 8y. Okay, well, obviously I need to times it by a negative, right, to get it from a positive to a negative. It's already 8, so I technically need to times it by minus 1. However, I need also to have a y. So because there's no y at all, how do I get from 8 to 8y? well, I also need to multiply by y, don't I? Now, I'm not obviously going to put 1y, because with algebra that's just unnecessary, isn't it? So all I'm going to put is minus y. And again, if you want to double check, okay, is my answer correct, you can expand it again, you can multiply out the brackets and check that that is your answer. Okay, this next one we now have a combination of letters and numbers that we can use as a common factor. So factorise 15x cubed minus 50x. Okay, so I know it's going to be single brackets. First of all, I'm going to look at the numbers. What's my highest common factor between 15 and 50? Well, I think that's pretty obvious. It's obviously a multiple of 5, so 5 is our highest common factor in terms of numbers. However, in this case, we also can then look at the letters. What's the highest common factor between x cubed and x? Well, they're both divisible by x, aren't they? So I can actually pull out an x as well. So my highest common factor to put on the outside is 5x. And then it's the same from here. How do I get from 5x back to 15x cubed? Well, the numbers first, I have to times 5 by 3 to get 15. And then this is x technically to the power of 1, isn't it? How do I get from x to the power of 1 to x to the power of 3, or x cubed? I need to multiply it by another x squared. Then I look at my next term. How do I get from 5x to minus 50x? So the first thing I'm thinking of is, okay, it's going to have to be a negative, isn't it? Because if 5x is positive and 50x is the negative here, I need to multiply by a negative. Then how do I get from 5 to 50? Well, obviously I have to times that by 10, and then x to x, well, that's just the same thing, isn't it? So actually, I don't need to put anything after that. So let's just move this bracket a bit closer, we don't need that much space. Okay, so that is your final answer. Okay, this one's a little bit tricky because we've got a few things to take into consideration actually. So, our highest common factor between those two terms. Let's first look at the numbers. 4 and 52. Well, actually, 4 is the highest common factor because 4 obviously goes into itself once, but it also goes into 52. So I'm going to pull out 4. Then I'm going to look at the letters. Now, this one's x to the power of 5 and this one's x to the power of 2. So the highest common factor is going to be your lowest power. So x to the power of 2. Now, there is actually one more thing we can pull out. As you can see, they are both negatives. So I am actually also going to pull out the negative. So my highest common factor is minus 4x squared. And then our process begins again. How do I get from minus 4x squared to minus 4x to the power of 5? Well, we've already got minus 4, so we're missing x cubed. And then the next bit, now, it's already negative on the outside, right? So that's why I'm going to make them positive on the inside. Because when we multiply negative by positive, the answer is still negative. That's what we want. So I'm going to put plus here. How do I get from minus 4x squared to minus 52x squared? Okay, well, 4 goes into 52 13 times. And the x squared is the same, isn't it? So we don't need any x's. So that will be just plus 13. So we've got minus 4x squared on the outside, and then x cubed plus 13 on the inside. Okay, so factorise minus 3 x to the power of 4y plus 51 x cubed y to the power of 5. Again, we've got single brackets, and my highest common factor, okay, 1's plus 1's minus, so I'm not going to pull out the negative, I'm just going to have a positive on the outside. Looking at the numbers 3 and 51, what's our highest common factor? Well, again, 3 actually just goes into 51 and obviously goes into itself. So I'm going to put 3 on the outside. And looking at the letters, now we need to look at them separately because obviously x is different to y, right? So looking at the x's, we've got x to the power of 4 and then x cubed. So the highest common factor is x cubed. You're going to take the smaller power. And let me just move this bracket along a little bit. And then we're going to look at the y's. So here we've got y, which is obviously technically y to the power of 1. And in the second term, we've got y to the power of 5. So in common, they both have y to the power of 1 in common, don't they? Obviously, I'm just going to write that as y, though. So our common factor, well, our highest common factor on the outside is 3x cubed y. So now on the inside, how do I get from 3x cubed y back to negative 3x to the power of 4y? Okay, well, first of all, you can see that we need a negative because the 3 on the outside is positive. They're both already 3, so we don't need to change the number. However, when you look at the x's, we're missing one x, aren't we? Or x to the power of 1. So I'm going to put x here. And again, the y's are already the same. So the only thing missing was the minus x. Then we say, how do we get back to 51x cubed y to the power of 5? Well, those are both positive, so I'm going to put a plus. Then we need to go, how do we go from 3 to 51? Well, we need to times that by 17. If I look at the x's, they're already the same, aren't they? They're both x cubed, so that's fine. We don't need any more x's. But the y's, again, this is technically y to the power of 1. So I'm missing y to the power of 4. So as you will have seen in the first video on factorising into single brackets, the concept of factorising is that we're basically putting the brackets back in, aren't we? It's the opposite process of expanding brackets. So with factorising quadratics with the trial and error method, we're going to be focusing on the fact that we need to find two numbers that multiply to make whatever this last number here is, and then also they add together to make the middle number. Okay, so this is a straightforward example because everything is positive. You can see it's plus 5x plus 6. So we're not going to worry about the positives, negatives and all that just yet. We're just going to deal with the numbers. So just remember, it has to multiply to make this last number here and add up to make the middle number. Okay, so thinking of two numbers, effectively what we're looking for are the factors of 6, and then we're going to see which ones add up to make 5. So factors are numbers that divide into, for example, numbers that divide into 6. Now, luckily 6 doesn't have too many options, but if you have a question where there's a lot of options, I always suggest starting in order. So what I mean by that is, well, I know it's going to be 1 times 6. Then I'm going to go, okay, does 2 go into 6? Yes, times by 3. And I go, okay, does 3 go into 6? Yes, but we've already written it down. So once I've kind of gone through all the numbers until I've kind of hit myself in the midpoint, I know that I'll have all of the factors. Like I said, for 6, it's pretty straightforward, but if you have a number that has a lot of options that might be almost larger than the times tables, just go 1, does 2 go in, does 3 go in, does 4 go in, until the point where you meet yourself in the middle, like this. The next number was 3, we already wrote down 3. So out of these ones, which ones add up to 5? Well, pretty obvious. I mean, clearly 2 and 3. So when we're factorising quadratics, we're going to have two brackets. If you remember expanding double brackets, you always end up with a quadratic, don't you? So we're going to get two brackets. We know that x times x will make x squared, so you can pretty much just put the x's in straight away. In this case, everything is positive, so we don't need to worry. We can just put plus and plus. And then 2 and 3, it doesn't really matter which way around you put them, because either way, they're just x plus something else. The brackets are the same other than that. As we said before, factorising quadratics is the opposite process of expanding, okay? So you can always go back and double check, have I got this right? Does this make sense? Let's say if I were to expand this just to show you, I would do x times x, which is x squared. I would do x times 3, which is plus 3x. 2 times x is plus 2x. And finally, 2 times 3 is 6. Then to simplify, I would just add together those in the middle, wouldn't I? So 3 plus 2 is 5. So you can see that's exactly the same thing. That's why you can see that we need to have two numbers that multiply to make this final number. Because this line of the expansion is where we get that final number by itself, isn't it? Just the two numbers multiplied together. So you can always go and double check your answer if you're not sure. Just expand it out again and see if it works. Okay, this is where it starts to get a little bit more complex because as you can see, it's not all just positives anymore. So I'm going to start out by drawing my double brackets because I can see it's a full quadratic. It's just x squared, so I know I can put x and x. And when you have a situation where it's not just all pluses, I'm going to actually deal with what type of symbols I'm going to need first. So if we write them up here, these are the options of the symbols. Okay, it's either going to be both plus in the brackets, both minus in the brackets, or a plus and a minus, isn't it? That's basically our options. As we said, if we have to multiply to make this last number, but the last number includes that plus, isn't it? It's positive 56. And we have to add to make the middle number, which is a negative. So think about it in terms of just positives and negatives. Okay, I'm multiplying two numbers, the answer is positive. But when I add them together, it's negative. So in this case, we're going to need both negatives. Two negatives, when you multiply them, cancel out to make a positive. But if you add them together, it's still negative, isn't it? So that's how I figure it out. Figure out your symbols first because it can then affect what numbers you choose, okay, if it's not all positive. So I put both negatives in, and then I can look at factors of 56. Okay, we know they're both going to be negative. So this is one where there might be quite a few options. Obviously, 1 and 56, I mean, you can see it's probably unlikely that that's going to be the case, but we'll write it down anyway. 2 and 28, and then we go, does 3 go into 56? No, it doesn't. And then you go, does 4 go into 56? Yes. 4 times 14. 5 obviously doesn't go in. 6 we know doesn't go in. 7, yep, 7 times 8. Then my next option would be 8, but obviously as you can see I've already written that down. So that's how I know I've written all of the possible factors. I've not missed any out. So these are my options, and then I have to figure out, okay, I know that both of them will be negative. Which ones would add together to make 15? Well, that would be -7 and -8, wouldn't it? So that's how I go through and check. Again, because they're both x minus, it doesn't really matter which way around you put the 7 and the 8, okay? They're both just minus. So a common mistake that people make is they look at the two symbols here and think, well, there's 1 minus 1 plus, so therefore in my brackets it should be 1 minus 1 plus. It has nothing to do with that. It's literally just focusing on, okay, I multiply to make a positive, but I add to make a negative. You know, what combination of symbols would make that work? Okay, the next one. So we're going through the same process, but you can see the symbols are listed differently. So I'm going to start off by just drawing my brackets. Again, it's just 1x squared, so I put x here and x here. Now we're going to see what symbols we need. So out of our 3 choices, 2 pluses, 2 minuses, and a plus and a minus. Now we can see we're going to multiply to get a negative. I don't really even need to look at the next number, do I? Because the only way to multiply to get a negative is if we've got 1 positive and 1 negative, isn't it? If we have 2 positives, well, there's just no negative involved anyway. If we have 2 negatives and we multiply them, they would cancel out and make a positive. So we have to have a plus and a minus. This is where it makes the difference as to when we figure out the middle number, okay? Because if you've got 1 plus 1 minus, when you add them together, technically this number here is the difference between them, isn't it? So that's why we need to know which symbols we need before we figure out the factors. So I'm going to put plus and minus there. And then factors of 21, luckily there aren't as many, 1 and 21. 2 obviously doesn't go in. 3 times 7, and that's pretty much it, isn't it? 4 doesn't go in, 5 doesn't go in, 6 doesn't go in, and then you're back to 7. So out of these 2 options, but remember that 1 is a plus, 1 is a minus, so you might want to list out even just writing it as plus this, minus that, and work it out. But effectively, this is the difference, isn't it? So 3 and 7 would give us a difference of 4. But we also have to figure out which one's the plus and which one's the minus. This is where it now is important. We can't just chuck in 3 and 7 as we want. We need to actually specifically put the right number with the right positive and negative symbol. So overall, we want it to add up to positive 4. So if we had -3 plus 7, that would give us positive 4, wouldn't it? But let's say if we had 3 plus -7, that would be -4. Either way, the difference is 4, so we know it's 3 and 7, but we have to make sure we get them the right way round. So in this case, we need the 3 to be the negative and the 7 to be the positive. Effectively, the bigger number is the positive, isn't it? Because our difference is positive overall. So our answer, we've got x plus 7 times x minus 3. Okay, our last question, again, very similar. Just go through the same steps. Draw out your 2 brackets because we know that it's a full quadratic, so we can use double brackets. Obviously, we want to make x squared, so x times x. Just put the x's there. Step 2, we want to find the correct symbols because it will affect how we end up adding them together in the end. So we've got plus, plus, minus, minus, and then plus and a minus. We're multiplying to make a negative. Anytime that you're multiplying to get a negative, you have to have one of each, don't you? So that's pretty straightforward. Put those in the brackets as well. And then we're adding to make minus 11x. So factors of 42, but the difference between them is 11. So in terms of 42, 42 is not a huge number. In that case, I guess our factors are a decent, distance apart, aren't they? Not too close. So obviously I know it's not going to be 1 and 42 because that's too far away, isn't it? We've got 2 and 21, still too far away. Does 3 go into 42? Yes, it does, 14 times. And actually, yeah, that's a difference of 11, isn't it? So we know it's 3 and 14, but which one is positive? Which one is negative? Well, if our overall middle term adds up to make a negative, we need the bigger number to be negative, don't we? So we need the 14 to be negative and the 3 to be positive. And you can check that out. You can go, right, let's say if it was -3 plus 14, what would I get? Well, that would give me positive 11, so I don't want that. But if I have 3 plus -14, that's where I would get -11. So this is why it's called trial and error. You literally just in the corner of your page, you can list all the factors, you can test it all out, try different combinations, just write it all down, because sometimes it's quite hard to kind of imagine it, with all the moving pieces of negatives, positives, numbers and all this. It can be quite difficult. So first of all, what is the difference of two squares? Well, as you can see here, we've got an expression that is x squared minus 16. Okay, well, first of all, x squared is a square number, isn't it? It is literally x times x, which is a square number. And 16 is also a square number, isn't it? It's 4 times 4. So those are the two squares, right? We've got a square here and a square here. And then the difference is always subtract, isn't it? If you want to work out the difference between two numbers or whatever it is, you're going to subtract them. So this is the format of the difference of two squares. And I tend to see a lot of questions like this, literally like 2 marks in an exam, but it's just so easy to pick up these marks because it's not even anything to do with trial and error method or splitting middle term or anything really. It's not even really a method. It's just kind of knowing what to do and you can just write down the answer immediately. So this is still a quadratic. However, you can see that we are missing the middle bit, aren't we? Normally our quadratics are in the form of ax squared plus bx plus c, and that's what we've been factorising, isn't it? They need to multiply to make c and add up to make b. Well, this is kind of true as well. It's just this one is x squared plus 0x minus 16. Okay, so it does technically have the middle part, but obviously we don't write it because it's just 0. But what we're saying is that the factors have to add up to make 0, or effectively cancel each other out. So, and I'm going to go through it in the trial and error method, however, when you actually work out what to do, you don't need to do it this way. You'll just remember what we need to do. So we're going to be multiplying to make minus 16, but they need to add up to make 0. Now, if you saw a trial and error method, you know that if it's just x squared, either way it's going to be x and x in each bracket, isn't it? Then we like to look at the symbols. We're multiplying to make a negative, which means we need a plus and a minus. And then you're going to say, right, factors of 16 that add up to make 0, obviously plus and a minus. Now this is where the square comes in, because if you want to add two things together and it to cancel out or to make 0, they have to be the same thing, don't they? Obviously one's plus, one's minus, but they have to be the same number, which is why it needs to be a square number, because we're going to use 4 and 4. So I'm just going to put 4 and 4 here. Now let's say if we were to expand this, you can see we'd get x squared, we'd get minus 4x plus 4x, and then minus 16. Okay, so you do have this middle bit. However, now if we then simplify it, you can see that the middle bit is going to cancel out. Minus 4x plus 4x is just 0, isn't it? It's just not there. And then minus 16. Okay, so I've obviously gone through kind of the background explanation, but my point is if you can recognize this type of quadratic where you've got ax squared minus, it has to be minus, right? Because we're obviously multiplying a plus and a minus. Ax squared minus c, you can still factorize it into 2 brackets. You just have to recognize that they're both square numbers. You need to do 2 brackets, one a plus, one a minus, and just the square root of each of these. So obviously the square root of x squared is x, and the square root of 16 is 4. You're not even having to really think about trial and error or anything. Obviously, I've just shown you how it works. But my point is, if I saw this question, immediately I'm thinking, right, x plus 4, x minus 4. I'm not even having to actually work it out, if that makes sense. So that's what the difference of two squares is. And I know a lot of students get stuck on this question because they see it and they go, well, I can't factorize it as a quadratic because it doesn't have the 3 parts. But I can't factorize it into single brackets because there's not anything in common. And then they're kind of stuck. So don't get caught up in that. It is still possible to factorize it into 2 brackets. Okay? Identical brackets, but one's plus, one's minus. So immediately, if you can recognize that this is the difference of 2 squares, it says factorize, literally this is what I'm going to do in an exam. Go, oh yeah, difference of 2 squares, okay, x plus, and then square root that, 11, x minus 11. Like I'm not actually going to write any working out, okay? The previous question was just me explaining why it works, or how it works. It's not saying that you have to do that working out in your exam, okay? I would literally just write down the answer like this. So that is everything you need to know about factorising if you're doing foundation tier. We've gone through how to factorise into single brackets and then how to factorise quadratics into double brackets. If you'd like to look at some more examples, if you want a bit more in-depth explanation, I will link the full videos down below so you can check those out individually as well. So thanks for watching this video. If you found it helpful, don't forget to subscribe, like the video, and just leave any comments or questions you have down below.